Hey guys, so Jeff Clark here again. We are continuing with our journey through trigonometry, and this section piggybacks onto right angle trigonometry, which was in the last section. Now we're going to have an even circles, but instead of having a circle that has a radius of 1, we're going to have a circle of any radius. And a right triangle is still going to be, instead of A and B, we'll have X and Y. And that being the hypotenuse, we're going to call it R. So instead of H for hypotenuse, this would be like opposite, that's adjacent, and that's hypotenuse. We're going to have X, Y, and R. And our definitions for the trig are down below, as you can see. And so y over r, now if you say, well, where in the heck's that? Okay, right here, the opposite over hypotenuse. Opposite of our hypotenuse, y over r is the sine, as you can see there. And then cosine is adjacent over hypotenuse. That's x over r. Cosine, there it is right here, cosine, and so on. Now, with quadrants, I think everybody knows this is quadrant 1 and 2, 3, and 4. I'm doing them in Roman numerals for you. It turns out that if you think about a circle in here, and if this is the x-axis as well, and this is the y-axis, wouldn't both the x and the y both be positive in quadrant 1? And the answer is yes. If both x and y are positive, that means cosine and sine are both positive. Cosine and sine, everybody is positive. So maybe A right here, A stands for all. It turns out all trig functions are positive. Think about it. All right, if x and y are both positive, wouldn't the ratio y over x be positive? Or x over y, which would be the cotangent? Cotangent would be positive. And the reciprocal of a positive number is still positive. So every function, all functions are positive. So when you see A Smart Trig class, A stands for all functions in quadrant 1. S, so this would be S right here. So that's A for all, S, this is T, and this would be C. Okay, T stands for tangent in the trig. This is sine, even though it says a smart trig class, that's just a way of doing the acronym. Sine, tangent, cosine. Sine's the only thing that's positive because the y's are positive. See how the y's are positives? Now, if the y's are positive, sine and its reciprocal are, what's that, cosecant? The sine and the reciprocal are going to be positive because if x is negative right here, the ratio, which would be tangent, for instance, of a positive number over a negative number is still negative. Sine is the only thing that's positive. Tangent is positive because if both x's and y's are negative, then two negatives make a positive. So tangent and cotangent, its reciprocal, are going to be positive. Everybody else is negative. And cosine is the only thing that's going to be positive here. So A Smart Trig class. All students take calculus. There's lots of different phrases to help you remember. A for all, S for sine, T for tangent, C for cosine in terms of the positive results that you get from those quadrants. All right, flip the page. Here we go. Let's take a look at this. If I try to plot this point -2, 1, so -1, -2, 1, 2, -2, 1 would be right here. That's -2, 1. And if I dropped a perpendicular here and went down to there, then this distance here is 1, and this distance right here is 2. And the question is what's the hypotenuse? And you guys know how to find that. Hypotenuse, let's call it R. R squared is equal to 1 squared plus 2 squared. R squared, which is the hypotenuse, is equal to 5. R is equal to plus or minus the square root of 5. But the radius, or R, can never be negative, so R is equal to square root of 5. So this is root 5. And now, if I want to find the 6 trig functions at that point, this is your y, this is your x. And by the way, when I look at that x, look at from the origins perspective. This is actually -2. That's the way I'm going to teach you right here. Even though this distance is 2, it's really -2 that's over on this side. So let's make that -2. And this is your R right here. So from the previous page, then, sine of some theta in quadrant number, this is a smart trig class. Okay, sine it better be positive. Sine it better be positive. That's y over r. So that's 1 over root 5. Yep, sure enough. Positive 1 over root 5. And if you need to rationalize it, you know how to do that. Cosine of, say, some angle theta. You know, angle theta be throwing me over there, which is an angle in standard position, equals x over r. And that's -2 over root 5. Tangent of that theta is y over x. So y is 1, x is -2. Let's do cotangent now. Reciprocal of that is -2. Reciprocal of sine would be what, cosecant. So take the reciprocal of that, which would be root 5 over 1, or just 5. And the reciprocal of cosine is secant, which should be -root5 over 2. Okay, next problem. Let's see. This is going to be x is positive, y is negative. Sounds like it's in quadrant number 4. Let's take a look here. Quadrant 4. So x is 1, 2, 3, and y is 1, 2, 3, 4. Yep, right there. So if I looked at this, I need that hypotenuse. So this is 3, and that's -4. So it looks like I'm going to have 3 squared plus a -4 squared is equal to r squared. This is r. 9 plus 16 is equal to r squared. 25 is equal to r squared. So r is equal to 5. You might have heard of a 3, 4, 5 triangle. Very famous triangle, 3, 4, 5. This is equal to 5. So here we go again. Sine. You might say it's this angle right there, which is positive. Or interestingly enough, if I did this one here, that would be negative, and it gets me to the same point right here. More about that later. So sine of, let's call that theta right there. Sine of that theta, which gets me to that terminal side, which is that dot right there, would be y over r, which is -4 over 5. Remember, r is 5. Let's do the reciprocal of this one now, which should be cosecant of theta. Okay, -5/4. Next one, let's do cosine. That would be x over r. It looks like I have 3 over 5. Now this is quadrant 4. A smart trig class, A smart trig class. Shouldn't cosine be positive? And it is. Look at that. That means sine should be negative, and it is. If cosine's positive, so should its reciprocal, and that reciprocal is secant of theta, which is 5/3. Tangent of theta is equal to y over x, which would be -4/3. And finally, cotangent of theta is equal to -3/4. And the next problem I'm going to take a look at is we just want to know what quadrant it lies in right here. What's the quadrant? What this says is sine less than 0 means sine is negative. Less than 0 means it's negative. And this one here says cosine is negative as well. So which quadrants would it be that sine is negative and cosine is negative at the same time? Okay, sine is negative. Let's see. Sine is, let's see, A smart trig class. Sine, I'll do that in blue. Sine is positive here and positive there. So sine is negative in these two quadrants. Cosine will do that in red. Cosine negative. No, C is cosine. That's positive. And so is that. So cosine is negative here and there. So where they're both negative, it would be in quadrant number 3. So the answer to this, Q3. Next problem. Let's see. Tangent of theta is -1/3. Cosine's got to be negative. Remember, this is less than 0. That means negative. Okay, so tangent is negative. Cosine is negative. Let's see where that is. Tangent is negative. This is everybody's positive here, but so tangent is negative here. Tangent is negative right down here. Remember that's all students take calculus, A smart trig class. Tangent is positive here, so it's got to be negative in these two quadrants. Cosine negative. Well, cosine is positive here and here. Cosine's got to be negative in these two quadrants. Where there's 2 check marks, I got to be in quadrant number 2. So I'll say in Q2. So the idea on this one is I'm going to draw my triangle. I'm going to draw a triangle so that -1/3 appears. And for a tangent, don't forget this is your y and this is your x. That's y over x. So where do you think the negative's got to go? To the y or to the x in quadrant number 2? Is the y negative up here or positive? Yeah, that's positive. The negative's got to go with the x. This has to be 1, 2, 3. This has to be -3 here, and then 1. The ordered pair right there has to be -3, 1. Has to be. So this is 1 here, -3. Here's your angle, theta. I need to find what's called the r, and we know how to do that. That's r squared equals y squared plus x squared. R squared is equal to y squared is 1 squared plus a -3 squared. R squared is equal to 1 plus 9. R squared is equal to 10. Therefore, R is equal to the square root of 10. And now we got to find the trig functions. Now, one trig function is already given, tangent of theta. That means the easy one would be, well, let's rewrite this. Tangent of theta is equal to -1/3. Cotangent of theta is the reciprocal, -3/1, or -3. Okay, next, let's do sine of theta. So sine is y over r. Sine is y over r. 1 over root 10. Remember, r is root 10. So 1 over root 10. Reciprocal of sine is cosecant of theta, which is root 10 over 1, or just root 10. Cosine of theta is x over r. That's negative 3 over r, negative 3 over root 10. And secant theta is equal to negative root 10 over 3. Next topic we're going to look at is called reference angles. And so reference angles got to be positive, and it's got to be acute. Reference angles have to be positive, and it has to be acute. Acute means it's bigger than 0, less than 90 degrees. So let theta be something that's not acute. So let's say an angle that gets over here, stops. And if this is theta right here, then the reference angle is it's a positive angle, and it's formed by the terminal side of theta and the x-axis. Okay, what does that mean? Here's the terminal side of the angle theta and the x-axis, the nearest x-axis. So don't forget, it's got to be acute. You couldn't go over here because that's not acute. The reference angle is right here. That's the reference angle. They call that theta prime. Theta prime is the reference angle. And now the question is the arrow, if it's got to be positive, the arrow can't go this way, cannot go that way. It has to go this way. So that would be an indication of the reference angle. Here's another one. Let's say I'm starting here and I'm going this direction. And this is your theta, gets me quadrant 3. The reference angle is the terminal side to the nearest x-axis, which is right here. So this is theta prime. Where's the arrow going to be? Again, it's got to be positive, so you don't want the arrow here. You want the arrow there. Okay, let's say I've got an angle goes this direction and it stops right there. That's my theta. Here's the terminal side. Here's the x-axis. It's got to be positive, so it's got to be an arrow that goes this direction. That's theta prime. 3 examples. So for instance, if I look at 210 degrees and I want to know what the reference angle is. Okay, 210 degrees, you can look back in the picture that you had before. When I say the picture, the wheel. Let's see if I can find a place where the wheel is located. It's a little easier. Let's back up the pages. Here it is right here. 210 degrees. Now you can see where 210 degrees is sitting over here. See 210, that's in quadrant number 3. I'm going to draw 210-ish about here. That's 180 plus 30, so this is 210 degrees right there. That's your theta. And then your reference angle has to be right here. So what's that going to be? Well, if 180 gets me right to stop right there at the x-axis, this has got to be 30 degrees left. Theta prime, which is the reference angle, equals 30 degrees. Seven pi over 4. Okay, let's see. This is 1 pi over 4, 2 pi over 4, 3 pi over 4, 5 pi over 4, 6, 7 pi over 4. Okay, it looks like I'm going to go, and it's positive. I'm going to go this direction here. That's 7 pi over 4. That's my theta. And this is my theta prime. And you need to have the arrow going that direction. That's got to be pi over 4. Remember, reference angles have to be positive. They are. And they have to be acute, which that is. That's smaller than pi over 2. Smaller than 90 degrees. Okay, negative 243 degrees. Oh, I got to go this direction. This gets me to negative 270. So I'm going to have to go, let's see, right about there-ish. That's my theta. This is theta prime right here. So here's an idea. 180 negative degrees right here. 180 degrees goes right here. This is the leftover between 180 and 243, and it's got to be positive. So I'm thinking if I took 243 degrees and backed off 180 degrees, that'll give me the leftover, and it needs to be positive anyway. If I took 243 degrees, 243, and I subtract 180, 63 degrees. This leftover right here is 63 degrees, and that's your reference angle. Okay, negative 11 pi over 6. Now it's negative. That's almost 12 pi over, that's almost 2 pi, right? 12 pi over 6 is 2 pi. So it goes this direction. I think we're right over here. That's your theta. This is your reference angle, but it's got to go this way. It's got to be positive. So this is theta prime. This has to be pi over 6. Because pi over 6 with a negative 11 pi over 6 all combined gives you 2 pi. 665 degrees. All right, that's a revolution. One revolution. Okay, this would be 1 revolution. That's 360. Let's see where I'm going to stop right here. This is, let's see, 665 degrees minus 360 degrees. Let's see, that's 305 degrees. So I need to keep going around until I get to another 305 degrees, which gets me about here-ish. This is theta, which is 665 degrees. So what I need is this part right here. So this is almost 365. I think if I took, I said 365, this is almost 360. If I took 360 and backed off this extra amount, which is 305, that gives me 55 degrees. That's the leftover. That is my reference angle. And finally, 5 pi radians. So instead of, this is a radian right here, but that's exact. So a decimal approximation to this. What I would do is do 2 pi and see how close I am to 5.9. 2 times, or 2, let's try that again, Jeff. 2 pi is about 6.28. Let's do, this value right here is probably in quadrant number 4. This theta prime exact would be, let's see, 2 pi, back it off, 5.9 radians. That would be exact. Decimal approximation, you can do that in your calculator on your own. So that's reference angle concept. These guys are just more of the same for you. Some of them are just a little bigger. When I say more of the same, you got to use your wheel again. So maybe I'll do a few of these. I'm not going to do them all. I'll do a cosine. I'll do a cotangent. I'll do that one. I'll do a secant. I'll do a cotangent. Let's do this one. What else do I need? Tangent? I don't see a tangent. I guess I might as well do this one here, a tangent. And I'm secant, cosecant. Okay, let's do that. So 1, 3, 4, 6, 8, and 10. I need to know where I stop here on my wheel, 450 degrees. So think about this. If I go complete revolution, which would be 360, I have extra left over. If I do 450 degrees again, that's 360 with some extra. It looks like 90. So I'm going to stop actually at 90 degrees. Cosecant at 90 degrees. Cosecant is the reciprocal of sine. I'm going to write sine up there. So I'm going to look for the sine of 90 degrees. And in your wheel, on your wheel, sine of 90 degrees is going to be 1. Sine of 90 degrees is equal to 1. And so since I'm looking for the cosecant, I'm needing the reciprocal of 1, which is 1. Okay, 23 pi over 6. Okay, it's more than 2 pi. So let's see. 23 pi over 6 equals. Okay, that's a 12 pi over 6, which is 2 pi. Looks like there's a little bit left over plus, what is it, 11 pi over 6. So I'm stopping 11 pi over 6. Cosine of 23 pi over 6 goes around a complete revolution and then continues, that's weird, continues to 11 pi over 6. And when I look at 11 pi over 6, and I'm looking at cosine, that wheel again, 11 pi over 6, here it is. The cosine is root 3 over 2. Root 3 over 2. Okay, negative 14 pi over 3. So I go negative 14 pi over 3. So I'm going to go revolutions again, complete revolution, 2 pi. So that's negative thirds. Let's see, 6 pi over 3 is negative 2 pi. That's a revolution. Okay, minus, let's do another one. I have to get up to 14. Okay, so that's 6 and 6 is 12. So I'm there. I got a little bit left over. So I got minus 2 pi over 3. So where I'm going to go is I've got 2 revolutions. I'm going to continue to go negative, and I'm going to stop at 2 pi over 3. So 2 pi over 3. Back over here to the wheel. 2 pi over 3. Negative 2 pi over 3. So it gets a little confusing when I have to go back this way. There's negative 1 pi over 3. Look at the denominator, pi is over 3. Negative 1 pi over 3, negative, here's the other one, negative 2 pi over 3. This is where I'm stopping right here. So I went around and around and then stopped. So this is where my thumb is. I'm going to look at, it looks like I need a tangent. See that? Tangent. So that's y over x, negative root 3 over 2 divided by negative a half. This is negative root 3 over 2 divided by negative a half. 2 negatives make a positive. 2's will cancel. I'm left with a square root of 3 when I'm done. Square root of 3, I'm done. Okay, negative 180 degrees. Well, that gets me to the same place as 180 degrees. Negative 180 degrees goes around and stops right here. Here's my ordered pairs. -1, 0. I want cotangent. So I'm thinking, let's see, tangent is y over x. Tangent is y over x. Cotangent is x over y. X over y. -1 over 0. This is -1 over 0. And that is undefined. Undefined. UD, undefined. Okay, 51 pi's over 6. Boy, that's a lot. 51 pi over 6. So I need 12 pi over 6 is a revolution. Seems like we did this one already before. Plus another 12 pi over 6. Another 12 pi over 6. So that's 48 of them. Yeah, we've done this one over. This is plus 3 pi over 6. So that's 1/2 pi, or pi over 2. Secant, this is the same thing. This will be the same thing as a secant of pi over 2. So pi over 2. Got to go back to pi over 2. Where the heck's the pi over 2? What's the ordered pair there? Pi over 2. Oh, right here. Okay, 0, 1. 0, 1. X is 0, y is 1. 0, 1. X is equal to 0, y is equal to 1. But I want the secant. So secant is the reciprocal of the cosine. Cosine is x. Has nothing to do with y. So here's your x. I want secant, which is the reciprocal. Oh, that's 0 over 1. So this is 1 over 0, which is undefined as well. This one is undefined. And the last problem I said I'd do would be 750 degrees. So 750 degrees is the same as 360 degrees, and plus another 360. That's 720 plus 30 degrees. So this is the same as negative cotangent of 30 degrees, because it gets me to the same place with 2 revolutions. 30 degrees, and I got a cotangent. 30 degrees, and I got a cotangent. 30 degrees, and I got a cotangent. Now, tangent is y over x. Cotangent is x over y. So the 2's will cancel. Root 3 over 1. Root 3 over 1. But there's a negative. Negative root 3 over 1. So that gives you some more samples of using your wheel to find exact answers. And got a couple more problems right here. Take a look and see how these will wrap this section up. We're at a quadrant number 2. All right, quadrant 2. Let's draw a picture right here. Okay, quadrant 2 right here. Okay, cosine's negative. Sure it is. Cosine's negative in quadrant 2 because it's all students take calculus. Cosine is positive down here, but it's negative up there. So draw your picture like this. Let's see. This is equal to x over r. R is never negative, so that's before. This has got to be -1. And if this is the y, yeah, I'm going to need a y because of sine and tangent both need a y. Then I'm going to use Pythagorean theorem again, which is y squared plus a -1 squared is equal to 4 squared. So y is square root of 15. So if I want sine and tangent, sine of theta is equal to y over r. Y is root 15. Now, plus or minus, it's got to be positive right here because it's above, it's quadrant 2. So square root of 15, not negative. And that's all over 4. And then tangent of theta is equal to y over x, which would be root 15 over negative 1, or just negative root 15. All right, this one here, let's see, tangent is negative. Let's see, which quadrant is tangent negative in? Well, let's see, all students take calculus. Tangent is negative here and there. Cosine is positive. Greater than 0 means it's positive. Okay, cosine is positive here and there. Oh, it's a quadrant 4, 2 check marks, means the quadrant. Quadrant 4 is how I'm going to draw my triangle. Okay, so I'm down here. By the way, you never draw your triangle this way to the y-axis. Never draw a triangle to the y-axis. It's always drawn to the x-axis here. Always. Never do this. Don't do that. Don't do that. That's not right. Okay, so here we are here. Negative 3 over 4. This is negative 4. This has got to be 3. Y over x. Y. I got that backwards. There you go. Happens every once in a while. So this has got to be y, and this has got to be x. So this has to be 4. This is negative 3. And when you do the Pythagorean theorem, you will get a 5 on here because that's the famous 3, 4, 5 triangle. And this is your theta right here. So now, sine. Sine of that theta is opposite over hypotenuse. Oh, opposite. Negative 3 over 5. And secant is the reciprocal of cosine. Oh, cosine is adjacent over hypotenuse, but the reciprocal would be 5 over 4. 5 over 4. Okay, folks, that leads me to the end of this section on trig functions. In this case, this textbook is 4.4. Okay, until next time, take care.